Hello, I'm Melissa Dinwiddie and welcome to Exergy TV, where we investigate topics surrounding sustainability in the Bay Area and beyond. On today's show, we'll be looking at the world of plastics. Are they really recyclable? What opportunities are there to reuse? To help us dive deeper into this trash pile, please welcome Jason Eno and Jason Reynolds, co-founders of PrintCycle, a new nonprofit that recycles scrap material from 3D printers. Hey guys.
Hi.
Well, to get us started, I want to first start by sort of setting the stage. And I know Jason Eno, I know you also work at Recology.
Yeah.
And I was wondering if you could give us sort of an overview of the situation with recycling of plastics. Like, what's the reality?
Yeah, so as you know, there's a blue bin, it normally has chasing arrows on it in like a triangle that represents usually recycling. And usually it's mixed recycling. So you'll have not just plastics, but different types of paper, cardboard, glass bottles, metal cans. And so what we do as Recology is we normally act as a hauler. So we collect the material and we take it to a processor or a MRF, a material recovery facility, where it gets sorted. So all that material from the blue bin, or sometimes some cities, just like Mountain View, their residents separate their cardboard and paper from their other types of recyclables. And the further you separate materials, the idea is that the more recoverable and the more recyclable those materials are, and the higher value they are. So that's kind of the issue, is that we're trying to use very streamlined systems to capture a lot of different material, different types of materials, find sellers or buyers for that material, so it can be reused or remade or recycled into new products and goods. That can be very challenging. There's a lot of different types of products, consumer goods that people buy and consume, and whatever's left over they throw away, but there's really no way. And so we try to make the best use of our resources by recycling. And it's really challenging. There's a lot of different types of plastics. Within the chasing arrows that you'll see, that logo, you'll see numbers, usually like 1 through 7. A lot of modern recycling programs don't really rely on those numbers, but it does indicate the type of plastic it is. And each of those plastics kind of have different markets that they go to, and they have different prices and values. And a lot of it also depends on how it's recovered and how easy is it for the processor to turn it into something akin to like a virgin material. And I think that's why we're here today, is because there's a lot of gaps in that system. We try to capture, as Recology, the most material that we can, so that we can kind of do it and recycle in larger batches and groups. But there's a lot of kind of niche plastics that get missed along the way. Sure. There's things like styrofoam is a very common one that we know it's kind of made of plastic-like material, or like polystyrene
yeah,
expanded foam, and things like plastic bags or film plastics. Clamshells usually aren't considered recyclable.
So the difficulty there is that you're getting a bunch of different material from a bunch of different resources or a bunch of different locations, pretty much omni material from omni locations.
Exactly.
So then you're trying to standardize a process to separate these materials and to get them into their proper designations so they can be reclaimed, reused, and recycled.
Exactly.
But then the difficulty is that the more mixed and the more that Recology wants to take in, which is a good thing, the more resource heavy it becomes to separate those materials out.
Exactly. and also the cleanliness of the material. So what the
Yeah.
condition is. Most of these materials, they're either like food packaging or they get mixed with other like waste that could contaminate that
Sure.
plastic. And
Pizza
so even
boxes.
I think
getting
that's
clean
something that a lot of
materials
people
is an
don't
issue.
necessarily think about when, you know, I have my food packaging and I drop it in the recycling bin. I often think, well, I don't know, maybe it just gets melted down and that food waste isn't an issue.
Right.
But what's the reality when it goes to the center where it gets processed? And then, you know, what happens to it? Does it, you know, what does happen to it?
Yeah, so say at your typical home in California, you'd have a trash cart,
Sure.
a cart for compostable materials or yard trimmings, and then a blue cart for recycling. And each of those carts would have typically have different drivers and trucks and routes that service each of those bins. So a single family home could have like 3 trucks going through their or by their home on the collection day. So what happens for recycling is all of those bins get picked up, they get mixed together, they get compacted into the truck. So a lot of those materials get compressed together. If there's glass, they break. The truck goes to either a transfer station where it tips the material onto a floor, and so you just have this huge pile of recyclable goods, and then all the other trucks, they dump their material, and then it gets consolidated together, put on a huge semi-truck, and then sent to a processor or processing facility. Where was I going with this? Yeah, so there's a lot of like.
It's a complicated process.
Yeah, it's complicated. A lot of the materials get compacted, and then what happens is they go and they get processed, they get separated out. There's a lot of screens involved, so there's these things called trommel screens that are somewhat like a big washing machine.
Sure.
With holes in it, like big
to
holes.
filter it out.
Exactly, to
Small-
filter out the
And
smaller
the end
material
result is
like
how much of that plastic actually gets reused, you know, gets recycled and reused.
So if you're talking about like the total weight, like the total weight of a load, and how much weight,
Or how much of the plastic that people, you know, actually, you know, put in the bin ends up being recycled and reused.
Yeah, if you
know.
were to like say throw away a pizza box, for instance, you think, you know, cardboard, I can throw this in the recycling bin, and the reality is,
well,
Or plastic, whatever.
a pizza box would go in the compost, so that's a
Right.
different process. But for plastics,
I think your
it
question
really
was,
depends on the type of plastic
right.
and how clean that individual piece of plastic is.
So for like a to-go container, it has a little bits of food waste, I think was a part of your question. So
Or that's just in general, how much
Yeah.
plastic that humans are using today, how much is actually ending up not in the, you know, landfill, but being, you know, actually recycled. We have this idea that, oh, it has that little number on it.
Right.
It's recyclable. I'm going to put it in the recycle bin. It must be being recycled, right?
Yeah.
But how much actually is?
I would say, even though this is going to be a misnomer, but even though I mentioned we don't go off of the numbers, the chasing arrow numbers for recycling, or to denote what type of plastic to put into that blue bin, I could tell you plastics 1 and 2 are far more recoverable than the other 5 or so that are listed. Like I would say less than 7% of those
Oh my
other
God.
numbers would give, and I think that's
Well,
a high estimate.
And that, like you said, it's due to that specific type of plastic. So there's thermosets and thermoplastics. So thermoplastics can be remelted, reused, reformed. Thermosets, like polystyrene, are difficult because those are thermosets. Once they are formed in that particular form, then that's it. They have to either be shredded and recycled
Aha.
in some other form. So you can't remelt it. If you were to raise its temperature, it would burn instead of remelt.
Oh, well, that brings us to what you two have recently
Sure.
joined together to do. I know that the two of you joined forces on a passion project,
Yeah.
completely unrelated to your job with Recology,
Sure.
and you formed this nonprofit called PrintCycle
We
to,
did.
to solve a small problem in the world of plastics. Can you tell us about that?
Sure. Yeah, so we met through Leadership Mountain View, and it was quite serendipitous. I had been in the 3D printing industry for almost a decade, and Jason working at Recology, we had a drink and we started talking about different projects that we could do, and we came up with this idea to start a nonprofit specifically to reclaim 3D printed scrap material from the 3D printing community and reuse that material to make useful goods. One of the reasons why we focused on 3D printing scrap material when there's so much material out there, and there are lots of programs that focus on reclaiming generalized plastic as well, is that 3D printing scrap material specifically doesn't need a lot of the screening, the cleaning, the processing that is generally used and is seen as a hindrance in the recycling industry. 3D printing scrap material doesn't need any of that. So it's a extremely useful and clean and ready to go material that people are already collecting. So if you go around and look at the 3D communities online, in subreddits and in channels and in different forums, the question that comes up on everybody's mind every so often is, what do I do with all the scrap material that I have from my 3D printing? I tried to print this big thing and it failed. Now I have this half-printed thing. What do I do with it? And unfortunately, the answer until now has been either to throw it away or to throw it in the recycling bin. And as we've seen with recycling bin, and especially firsthand, is that those processes and those facilities are designed for kind of the omni material coming in. They're designed for everything to come in and then separate that material out. Here you have a community that is already separating their material. They're already using the right bin, the blue bin or the compost bin. They're already using a separate bin, which ends up taking the form of like a cardboard box that they keep in the side of the corner of their workshop. And they throw in their scrap material there, and it collects after a number of months or years, depending on how much the person or individual is printing. And we are trying to create a system where someone can use a bin like our PrintCycle bin that we've developed, keep this instead of their cardboard box, deliver it to us where it can be shredded and reused in a more of a streamlined system that we can use to make useful goods, to make scrap material. This is actually from my 3D printing business that I run as Jinxbot 3D Printing. This is my material that I collected, not all of this, but I had about 8 years worth of material. And so as the average hobby printer, they would have maybe a small box or something. I had about 8 or 9 of these bins that I had filled up over the years. We try to print as streamlined as we can, so we didn't have too much, but 8 years plastic that I was storing. I didn't want to throw it away. I didn't want to recycle it because I knew it was good, valuable material, near virgin material. So when getting involved with Maker Faire, I got in touch with David Schick of Peninsula Precious Plastics. Precious Plastics is a global organization that focuses in on recycling 3D printing material, or not, I'm sorry, focus on recycling all plastic material all throughout the Bay Area. So he has giant industrial plastic shredders. He has injection molding equipment. His goal is to perfect creating giant plastic 4x8 sheets of like 3/4 inch, where it can be used in furniture manufacture, recycling in making flower pots, injection molded goods, making clipboards have been a really popular thing. Things that don't necessarily need to be 100% virgin raw material, but can be used, recycled, injection molded and done. So he has all that material, has all that. What we're doing is feeding him clean, pre-sorted, and near virgin material, which he can then shred and turn into goods. So instead of having to sift through clamshells, looking for high density polyethylene, low density polyethylene, polyethylene terephthalate, the fancy name for ABS, acetyl butyl styrene, all of those fun plastic turns. So instead of him having to collect all of that material, separate it out, which he does at his local facility in the peninsula, we're giving him a box of ready to go PLA, polylactic acid plastic, which he can then shred and turn in directly, reducing the cost and labor for him and reducing the amount of waste in the ecosystem.
Okay, now I have a technical question about
Sure.
this scrap. Don't 3D printers use a variety of different types of plastic materials?
Absolutely. When 3D printing first started, there were kind of two dominant plastics that people started using. The first one was ABS. And ABS was really good because it was cheap and it was easy to get a hold of, and 3D printers were looking for this. This is actually a specific of the filament. This is what it looks like raw as it comes in the spool. So if they had ABS, they would feed it in there. The problem with ABS is that it had a tendency to warp, and it's a fairly toxic material, and it's difficult to recycle. It is thermoplastic, so it can be remelted, but again, you're off-gassing harmful chemicals. So if, just to give you an example, ABS off-gases in the parts per million. So in that type, you can smell it as you walk by, it has an odor to it, etc. PLA off-gases in the parts per billion.
Oh, wow.
So it's 1,000 times less. So if you were to walk by it, unless you were really looking for that odor, you wouldn't be able to smell it. It doesn't create films anywhere, and it's fairly clean material, much more dimensionally accurate. And so the 3D printing community and industry and additive manufacturing in general has moved more towards using PLA as more of a standard. However, that being said, there's ABS, there's PLA, there's TPU, which is a kind of a rubberized material. There's impregnated different types of PLA, metal-filled, wood-filled. There's a whole bunch of different types. The fortunate is that if it's PLA as a base, it can be recycled and reused together because it's a similar melting temperature material.
Okay. I was going to ask about that. Does it cause problems if
Sure.
people have a box that's filled with a variety of different types of materials?
It would, and that would have to be dealt with in a special way. We'd have to separate that out, and there's ways to identify it based on density and a couple different other tests that you can do. But the benefit is that these 3D printing enthusiasts, I'm not calling them nerds, they're enthusiasts. I'm one of them, no worries. But we are already separating the material by the material component. So maybe not necessarily by color, but all of that you see here is PLA. So the pigment itself doesn't change its mechanical properties too much, in that it would make it a dissimilar material. So you can use all of this material as PLA.
Okay, cool, cool. So you talked about the journey of the plastics that we recycle, food waste, plastics or whatever, and how that all gets jumbled together and then it has to be sorted out, and that it's such an imperfect process and results in so little being actually recycled. What is the journey of a piece of 3D printing scrap material
Sure.
from collection to becoming a useful good, like a flower pot or something else?
And just really quickly, so if you were to try to dispose of this printed scrap with Recology, or really any city within California that I know of,
Yeah.
they would tell you that this material would be landfilled or go into the trash.
Right.
Because really this is a market-driven system,
Yeah.
and if they can find end buyers for that material, then collect it. But if they can't kind of collect enough and find a buyer, then they won't collect it, or they won't. Yeah.
And on a 3D printed good, there's no triangle that would allow a consumer to recycle this. This person designed this themselves.
Right.
So where it's lack of knowledge. It's education.
Yeah.
It's allowing people to know where and how to recycle this material.
Yeah, but also like a lot of people would try to probably put like, because they would think plastic. They would it's wish cycling or like greenwashing or aspirational recycling or what have you. But like I think people really understand a lot of the environmental impacts of pollution and kind of like plastic waste and use, and they want to have it recycled and they want to do what's best for that material.
Right. But they don't know how.
But they don't know how, and there's not a system for them to do so.
It's path of least resistance, right? If you make it harder for someone to recycle something, they're not going to do it.
Yeah.
But if you make it easy and they know where to go and they oh, well, this isn't too bad of a system, I'll go ahead and just keep my material and then I can send it off to PrintCycle.
And that's what your goal is to eliminate those hurdles and those hoops by offering people the bin.
We want to make it dirt simple for people to understand where to go to recycle this material. And not only that, but then to be able to reuse this should they choose to. We want to make this material, so as a nonprofit, we want to make this material available to people who want to use it to make useful goods. Injection molding isn't a terribly difficult process to do. In fact, there's a lot of home units that can use this material to make your own flower pots or hydroponic cases, and there's a number of different things that you can use that it doesn't necessarily have to be FDA grade approved virgin plastic. So to go back to your life cycle question.
Yeah.
Someone would 3D print a scrap or a boo-boo or an accident or something that they didn't mean to print, or maybe it failed halfway through and they don't know what to do with it. So then they put it in a cardboard box or hopefully one of our PrintCycle bins. As soon as it gets to the filled mark, they can bring it down to one of our collection points. One happens to be at my shop at Jinxbot off of Church and Calderon in Mountain View. And then we collect that material, make sure it's a homogeneous material inside that same bin. We weigh it. We have NFC chips that are embedded into the bins so we can keep track of who's delivering it or who's donating it, what material, what weight, etc. And then we deliver it off to David Schick of Peninsula Precious Plastics, where he would then shred it. And then we can work with him to make kind of generalized goods like the clipboard or some of the keychains or coasters that you see here, or maybe the 4x8 sheets. And then we can also work with corporate sponsors to then make tchotchkes that are branded out of their own scrap material. So if, and this isn't just hobbyists too, this is schools have 3D printers, hobbies have 3D printers, small to medium-sized businesses, large corporations have these fabrication labs. And again, they're doing the same thing. They don't know, or there's no resource for them to be able to dispose of this near virgin material effectively. And we want to be that source for them.
That is so awesome. So looking at, you've got these flower pots and coasters, keychains.
Yeah.
So what are some of the most innovative products that you've created from recycled materials? And also, what has the community response been?
The community response has been hugely positive. I mean, they're fun. They have different colors kind of woven through. They have a kind of a tie-dye effect. And some of the fun things that you see have been some of these as well. So the clipboards, again, have been wildly popular, oddly enough. And then eyeglass frames, chess pieces, any sort of tchotchke that you can think of that can be even branded too, can be easily made. So it's rife with possibility. It's raw material. It's whatever your imagination comes up with.
I love it. I love it. So I know this has been quite a project, you know, creating a nonprofit and figuring out all of, I would imagine a number of hurdles. What challenges have you overcome in this project and in handling and transforming scrap material, and how have you overcome them?
Well, I would say we've gotten this far because of the connections we've made through the City of Mountain View's Chamber of Commerce via their leadership Mountain View group. So yeah, we were able to leverage a lot of like insight and knowledge from the different nonprofits in Mountain View and organizations such as CSA. I don't know, even going through like the use permit process and knowing people that that have been through those processes before, I think really helped us out.
Yeah, I've started a different company in Mountain View before, and I know how difficult it can be. This has been a relatively easy project to go through. The momentum has been there, the desire, it's almost been pulling us through the system. So it's very apparent that people are interested in this as a project and want to donate. I mean, we had barely opened up our doors, so to speak, and we're already getting unsolicited phone calls going, I have a bin of scrap material and I don't know what to do with it. Can I give it to you guys? And we're like, absolutely, our doors are open for you.
That's fantastic. Well, the need is clearly there, and you have figured out a way to fill it, so that's great. I'm curious, are there plans to expand the types of products that you create or the methods that you use for recycling and reusing materials?
Yeah, the sky's the limit. Whatever someone would want to create is really up to them. It's at the difficult and the niche part that we have addressed is essentially a delivery system for this material. Once it gets to the point where we have shredded material, then it becomes a standard manufacturing process at that point. We're using, traditional machinery and injection molding equipment. So if someone comes to us with a specialized injection mold that they'd like to use with our specialized 3D printed scrap material, we can absolutely handle that request.
Wonderful. What I love about what you two have done is that you've identified one specific area where you can really make a difference in this seemingly overwhelming, impossible task of, oh my God, plastic, it's, what can anybody do?
Sure.
This is an example of how two people have come together to solve a problem and make a big difference.
Right.
And I really applaud you for that.
Thank you. It's not necessarily single-use plastics, or it's not necessarily plastics, it's single-use plastics. That's
right,
the issue.
for sure,
So
yes.
if we can give that a second life, we've done our job.
Yes, absolutely. So is there one thing that you would say to anybody watching that, that they can do?
Well, I just wanted to point out, I think it's very unique and rare in this industry to have the whole process localized.
Sure.
So within basically our own county or our part of the South Bay, there's the waste that's being generated here, it's being collected here, it's being shredded and processed here and being turned into like a new tangible product here that people can buy,
right,
or enjoy or consume or whatever. And that's something that I can't think of a single example in the country where you have a closed system like that,
right,
and doesn't involve like shipping overseas.
Yeah. Well, I thank you both for being here and for setting such a great example of how you can actually make a difference in an area that seems overwhelming.
So our last note then would be to use PrintCycle, go to our website, printcycle.org, and learn more about our process. And if you're local and if you have a 3D printer, whether or not you're a hobbyist or a school or a small business with a few 3D printers doing some rapid prototyping for you, contact us and we'll take care of that waste, or not waste, scrap material. We'll take care of that scrap material for you and we'll turn it into useful goods.
Wonderful. Thank you so much, Jason and Jason, for being here today. This show would not be possible without the crew, so special thanks to all of you. My name is Melissa Dinwiddie. Thanks all of you again for watching today, and join us again for another episode of Exergy TV. Bye-bye.